This is the offline programming, so the interface may look a little different than what's on the machine, but the code is 100% the same. So it's going to, use a lot of behind the scenes parametrics to do all the movements and that type of thing. I just really have to define the blank in my measuring position and then the bend angle and direction if necessary. So we go to the master program. So I hit program edit, and then I move over and enter the variables. So this is where it's helpful to have a flat pattern. So I enter the flat length and then the width, and I'm not used to this, so I'm a little slow. And then I come down and enter the sheet thickness. So it's automatically positioned the blade based on the thickness. And really this is the only difficult part, is the measuring position, because we have 3 points to measure to figure out that triangle to make sure it's square. So after this video, I'm going to show you where I get these values from. But I enter the variables 5 through 10, which are my measurement points. And the last one is I'm doing parametric, so I'm taking off a 1/4 inch based on the sheet length. That way, if I have a similar part that maybe grows by 20 inches or something, it will automatically adjust that last variable. And we can get into a lot of variable programming, but this is a very simple part. So I really only have one flange on each side, so I have to scroll down till you see the last flange. There are 4 sides to the part, so I enter the same value on all 4 sides. And notice it is old school, where I have to remember to put a leading 0. So I cannot put 0.950. I'm putting 0.950, which basically I'm taking off a metal thickness for stretch out. And then I come in, and the template is set up for a 4-sided part. So I have to delete the first 3 bends. And then the software is going to figure out all the movements and everything. And then I would go over and save the program, and this is ready to run. So, there are certainly more complicated programs. Like if you have a down bend, then I have to enter a command to tell the folding beam to move in the up position for a down bend, but then I just insert the line to do that. So it's very straightforward, but again, your software may look a little different. I sketched a CAD file just as an example. Again, this is your part NBH00912. So this is what the flat would look like, and you could see my corresponding sheet length is 36779, and the width, I didn't draw it, is 24279. Measurement point 1, the laser is going to move in this direction. So I come down, you could see 1.009, and then I'm moving over variable 6, 250. So that's where my laser eye is going to measure. Then measure 2, I'm going to measure in this direction. So I come over 1.009 and I come down 0.5. I could have also made this 250. It just really has to hit somewhere on this flange. And if there's not a notch, you can reference on the square edge. I like referencing in notches, because typically if it's coming off a turret or something, your parting tool is not as accurate as your corner punch. So I always prefer to reference in a notch. And then my measurement point 3, again, I'm coming down 1.009, and then I have the sheet length minus 250 to come in and reference here. So that's how we get the reference positions.